going to demonstrate another division problem for you, probably two in this practice set, practice set of problems, because we're going to move away from the past few lessons I've had you draw out. I've made you draw out the groups, creating circles and putting items in the circles to really drive home the point of grouping, which I'm going to continue to remind you of until you're tired of hearing it. But division is grouping. We're dividing things up into group. We're dividing 75 up into 5 groups, specifically with this case. But since the numbers are just going to get bigger and bigger, we're not going to continue to draw circles, because that becomes inefficient, and you will make errors with that inefficiency. So we want to jump to something that's more efficient, and this is where really algorithms or methods come in math. Eventually, some guy, some girl, some person needs to develop a system to manage these numbers efficiently as they get big, and that's where the algorithms come into play. Now there is a lot of understanding built into the algorithms, but it's basically a system for managing this efficiently. So now I'm going to start training you to use this as a system in an efficient way to do this grouping, so that we don't have to draw circles when we get numbers like 1,000, which would take us all day. So this is how the process works, and I'm going to use we're not going to use the standard method completely yet. This is actually a stacking method, because it reminds you of number value of place value. Now that's why I have a place value chart up here to refer to, because we need to remember that in a 2-digit number, 5 is in the ones column, 7 is in the tens column, so that's actually 70, and that's actually 5. So I'll continue to repeat those things as we go through this stacking process. So here's how the system works, and we'll do this enough that you'll just start to get it down. The first question I ask myself, and you always train your brain to ask questions in math. So what's the question? The question is, will 5 go into 7? And if the answer is yes, the answer is yes, because 7's bigger than 5. So I can break 7 up into at least one group of 5, and I can do it in exactly one group of 5. There will be some left over, which we'll see in a minute. But actually, since I'm breaking up the 7 into 70, so I can break it up into 10 equal groups. So 5 times 10 is 50. And then I subtract to get what's left over. There's still 25 left to divvy up. So I've distributed 50 of those items. I have 25 left to distribute, so I ask the next question. Now I'm down to here. So the first question is, will 5 go into 2? And the answer is it won't, because 2 is smaller than 5, so I can't break 2 up into 5 groups. But will 5 go into 25? And then I have a yes now. That's a double-digit number, so it'll obviously go in. And we know that we have an actual fact here, and I'm going to put it right up here. It's 5. 5 goes into 25 5 times. 5 times 5 is 25. And I have a 0 remainder. And I put the 5 in the units place because it goes in it's 5 times 5, not 5 times 50. 5 times 5 is 25. So then when I add these two up, 10 plus 15, my answer is 15. So the answer to that problem, how many groups of, if I broke 75 into groups of 5, how much would each group have? The answer is 15. Now let's do another one. And I'm going to take 48 divided by 3 this time. It's going to be very similar. Put it into the standard structure for completing a division problem efficiently. Again, we're going to use what I call a stacking method. Eventually we won't use the stacking method anymore, but it's just, we're still trying to train your brain to see actually what's going on. When I break up these groups, we're still grouping. I shouldn't have erased that fact. We're still grouping. So then to the questions. The question is, will 3 go into 4? Since 4 is bigger, it will. I can break 4 up into at least one group of 3. And I can do exactly that. 3 times 1. But since it's over in the tens place, I'm actually taking 3 times 10, because this number is not 4, it's 48. 3 times 10 is 30. Now subtract to get the difference, and we get 18 as a remainder. So I've taken 30 of those items, distributed them into the equal groups like we did last time. I've got 18 remaining, so let's keep working on it. So now we go back to this. We're done with this when we go down to this number, because we've already taken 30 of them out. We have 18 remaining now. Will 3 go into 1? Answer is no this time, so I go to the full number. Will 3 go into 18? Yes. Look at my multiplication table. I know a fact. 3 times 6 And I put it in the ones column this time because that's all I need. 3 times 6 ones is 18, and with a remainder of 0. So what I have is when I've broken up the 48 into 3 equal groups, each group will have 10 plus 6 or 16 items in it.